Hee-haw! That's how they said hello in the movie It's a Wonderful Life. It's a great black and white movie for Christmas time. You guys should totally watch it if you haven't seen it. And I thought I'd say something different than, hey, it's Emerald. Besides, my husband thinks that hee-haw is hilarious. So, aside from the normal hilarity, let's do our scaling notes. If something is drawn to scale, it is proportional to the original. It's a reduced or enlarged two-dimensional drawing. And it's highlighted in gray, but you should probably use a different color and highlight it again. And write down the other things I said, which means it has a constant of proportionality, which we used to call K, and we used to call unit rate, but today we're going to do all the same things, but we're going to call it scale factor. So make sure you write that down. So when I go to do this, instead of doing y divided by x, we're going to do the new measurement divided by the old measurement. So you need to know which sides correspond, and you need to know what that means, and it means matching. So write down that corresponding means matching. So here's the example. Derek's family took a day trip to a modern public garden. Derek looked at his map of the park and saw that it was a reduction of the map at the location of the entrance. The dots represent placement of rare plants, and the diagram below is the top view as Derek held his map while looking at the posted map. Are these maps oriented the same way? No, they are not. What would you have to do to this small map to make it look like this map? It's a geometry question. What would you have to do to this map to make it look to have the same orientation as the other one? You could turn it 180 degrees. So if you turn this 180 degrees, then everything will be facing the same direction. What point would A match with on the other map when you turn it 180 degrees? What point would V match with? And H and Y. So I'll do A, and then you guys do the other ones, and then unpause the video. A, right here, has a bend, and then it goes like this. It goes towards this shape and past the circle. So towards the weird shape. So it's not going to be this one because it's not towards the circle. It's this one, towards this weird shape, and then past the circle. So A is going to match with R. Go ahead and try the other ones without me. V is going to match with W. It's the same spot on the map. Even though the map's a different size, it's on the same spot. H is at the intersection of two lines, so is P. Y is on the curve with a flat piece, and N is on the curve with the flat piece. You have to figure out what corresponds for you to be able to write ratios, and that's why this is in my ratio chapter. So at the bottom, we're going to do the correspondence, and then we're going to find the scale factor. So the first thing I want is the height of this. Now, most times students count lines. We don't want to count lines. We want to count spaces. How many spaces is on this side of the rectangle? And it is 18. The original height is 18. And the original length from here to here, from 7 to 13, is how many spaces? 6. What is the height of the smaller picture? Well, that goes up to 9. And the length of this from 7 to 10 is 3. So which sides correspond? Well, the height corresponds with the other height. The length corresponds with the other length. So I like to draw arrows to show where I start and where I finish as far as how things match. Just like we did y divided by x is k, I'm going to do new new number divided by old number. So I'm going to write that formula down because that's how I could do scale factor. Is new divided by old. That line means divide. My new height of 9 compared to, in a ratio, compares numbers, my old height of 18. My new length of 3 compared to my old length of 6. Celeste drew an outline of the building for a diagram she was making, and then drew a second one mimicking her original drawing. And I want to see if this is proportional. So you can do division, and when you do division, you're going to get a decimal. And in 7th grade, fractions are really the theme here. So let's just do the fraction button and reduce this. 9 goes into 9 once, 9 goes into 18 twice. 3 goes into 3 once and into 6 twice. This is equal, so it is to scale, it is proportional, and my scale factor is 1/2. The scale factor, just like constant of proportionality, is the number you multiply this by. Like this used to be y and x. So if I multiply this by 1/2, I will get 9. If I multiply this by 1/2, I will get 3. This is half the length and width of the original picture. Okay? This is the number you multiply by. The scale factor is the number you multiply by. Okay? You have another problem on the other side. I want you to do that one on your own. When you're done doing it, unpause the video and check your answer. So in this example, Luca drew and cut out a small right triangle for a mosaic piece he was creating for an art class. Mosaic is a pattern. His mother really took a liking to the mosaic piece and asked if she could create a larger one for her living room. Blow it up. Luca made a second template for his triangle pieces. So in the first picture, the height is 5. In the second picture, is 15. In the first picture, the width is 3. In the second picture, it's 10. The height compares to the height. The width compares to the width. I still like to draw the arrows. So I write a ratio of new divided by old. New number divided by old measurement. And I did 15 over 5, and then 10 over 3. 15 over 5 is 3, and this is not 3. This is like 3 point something. They're not equal. It's not a constant unit rate, so it's not proportional, so it's not to scale. If Luca's enlarged mosaic, is this a scale drawing? No, it's not to scale because it's not proportional. Okie dokies? Let's try another problem. We got over here, all these lessons are similar, so I put them all in one lesson. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. I like to summarize and write that down so I don't have to reread it. Each square in the drawing is 1 by 1. It's centimeter, 1 centimeter by 1 centimeter. 1 centimeter squared, because centimeters times centimeters is centimeters squared. Every squared. Squared. So you can see why they call it squared. Find the actual length and width of the garden based on the information given. I think a lot of you are going to like showing your work in the form of a table. So in their last few assignments, some of you did work like that. It just wasn't quite so organized. So stay organized, label the table. You gotta label the table. So if every edge of the square is 1 centimeter, how long is the edge of this garden in centimeters? Count it up, and you get 8. What's the height, or the, what is it? This is length, and we'll call this one width. What's the width of this garden? 1, 2, 3, 4. One more time. Do not forget, we are counting spaces, not lines. So this is 4, not 5. It's 4 blocks. 1, 2, 3, 4. Okay, I want to know what that is in meters. Well, if 1 centimeter is 20, how do you go from 1 to 20? Remembering our definitions of constant of proportionality or scale factor. The scale factor is the number you multiply by. What do you multiply 1 by to get 20? That would be 20. So if you multiply these by 20, you will get the actual measurements in meters. So it is going to have a length of 160 meters, and it is going to have a width of 80 meters. Capiche? You capash. Okay, the next example is done for you, and if you're looking at it on the computer, it's in beautiful color. I have Jake created a simple game on his computer and shared it with his friends to play. Apparently Among Us is very popular today. They were instantly hooked, and the popularity of his game spread so quickly that Jake wanted to create a distinctive icon so that the players could easily identify his game. He drew a simple sketch. From the sketch, he created stickers to promote his game, but Jake wasn't quite sure if the stickers were proportional to his original length because every child is thinking, is this drawing proportional, Mom? Okay, so they're not, whatever. So here's the picture. When you make an icon, and if you don't want it to be proportional, it doesn't have to be. But when you're taking pictures and things, you want stuff to be proportional. Because if you stretch somebody out, that would look really weird. So anyways, so we got a box pretty much, or a cube for an icon. You have to figure out which sides correspond. You can see I drew the arrows between the corresponding sides. I put them in the table, labeled them the new sticker and the old sketch. And I wrote down all the numbers that corresponded, and I did new divided by old, and every single time I got the same number because it is proportional and it is to scale, and that scale factor is 2. This is twice the size. So why don't you try number 3 on your own? Your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your phone and send it to her. If her original portrait is 3 by 3, I always like when I hear stuff that I can draw, I draw it. So I got a portrait, it's 3 by 3, the sides are the same, so I draw these little dashes to show that sides are equal, because you should get used to that notation. This is a square. Square has 4 sides equal. This portrait is a square. It is 3 feet by 3 feet. I'm going to label the units. The scale factor, what did we say scale factor's definition was? The scale factor is the number you multiply by. This is why we do vocab. This is why we do definitions. So I underline that because it's important. Whenever you do word problems, you should be underlining the important information. Draw a scale drawing that would be the size of the portrait on your phone. Okay, legit, not going to draw this 3 feet for real. Don't have room on my paper. If I'm multiplying by a fraction less than 1, do you think this picture is getting smaller or bigger? Multiplying by a fraction less than 1 is going to make my picture tinier. So you could put it in the calculator, or you can do it old school. 3 goes into 18/6, so that's why this would come out 1/6. And what are the units? It's feet. Do you ever hear somebody say, how much do you need? I need 1/6 of a foot. No, people don't say that. If you're getting under 1 foot, you're probably measuring it in what? If something's smaller than a foot, you normally measure in what? Inches, right? What you know about feet in inches? I know 1 foot is 12 inches. I have 1/6 of a foot. So let's see, how do I go from here to here? Remember, we're doing multiplying almost all the time. When I divide, I'm basically just multiplying by a fraction anyway. So this is times 12, right? So if I do 1/6 times 12, what would you get? Use the calculator, play it safe, get it right. 1/6 of 12 is 2 inches. It'd make more sense that somebody say, I need a 2 by 2 inch scale drawing. I'm not saying 1/6 of a foot is wrong. I'm just saying nobody says that. So let's talk common talk here. 2 inches. All right, what do you remember about area? You should have learned area in the previous grades. What shapes are these? You should know your shapes. This shape has opposite sides congruent. Let's just go over a little bit of notation that we're going to be using pretty often. A 1 dash is equivalent to this opposite side of a 1 dash. A 2 dasher is equivalent size to another 2 dasher. Okay? A little bit of notation. You should know it. I want to know the scale factor. So this is the actual picture, and this is the scale drawing. This 6 turns into a 2. The 9 turns into I blocked it a little 3. So we're going to write a formula down. Get in the habit of writing a formula and then substituting it in. Okay? The 6, is that the new number? Nope, the new number is 2. So it goes 2 for the new, 6 for the old. They match. And then I got 3 over 9. These should come out equal. It's supposed to be a scale drawing. So 2 over 6 and 3 over 9 both reduce to 1/3. The second picture is 1/3 the length and the width. Now let's talk area. Again, what did I just say? If I'm going to do something, I'm going to do it with a formula. So area of a rectangle is, for any parallelogram where opposite sides are parallel to each other, meaning they never touch, it's base times height. Base and height have to be perpendicular. Perpendicular means they make a right angle. The base here is 6. I'm going to substitute. So I'm going to plug the numbers in. The base is 6. The height is 9. 6 times 9 is 54. Okay, let's do that again. Area of a rectangle is base times height. The base and height have to make a right angle and be perpendicular to each other. So that would be 2 times 3. You might be saying, why aren't you doing L times W? L times W is so old school, just like X is an old school time sign. L and W are not something I'm going to use because it's not as useful as base times height. If you learn the base and height, you have less to know because I'm going to use these in lots of formulas, whereas L and W are only used on occasion. I like all-purpose tools. All-purpose tools. Base and height is like an all-purpose tool. We're going to use it more often. 2 times 3 is 6. I want the value of the ratio. Ratios are comparisons. Often we do comparisons with a fraction bar. We used to do them also, you know, with the colon there. What's the value of the ratio of the scale drawing to the actual? Scale to actual. Do it in the order it said it, which is called respectively. Respectively means do it in the order that it was said. So scale drawing, fill it in, 6. Actual, 54. This will reduce to, put 6 over 54 in the fraction and press enter, and it will reduce it for you automatically, which would be 1 to 9. 1 scale to 9 actual, or you can do 1 over 9 like that. I have another example right here for you already done. Your work would be for you to read that and look at it when you need help on the homework. Then I have some questions here at the bottom. What do you notice about the ratios of the areas? Complete these statements below. I might have skipped the question for this one. So, when the scale factor of the sides was 2, meaning the sides were doubled. So since I skipped the example, you make one up. So let's say I take a square, and the easiest number I can think of is 1, because a 1 by 1 square is a 1 squared. 1 squared, 1 times 1, is 1. Now if I double it, this is super easy to double something that's times 1, it's 2 by 2. If a square is 2 by 2, the base times the height is 2 times 2, otherwise known as 2 squared. Hence we call it, why I always call it a square. 2 times 2 is 4. I went from 1 to 4. So it is times 4. The scale factor is the number you multiply by. When you double the sides, you quadruple the area. That's what I would like to do with my family room. I would just like to give me a little bit more length and a little bit more width so I can quadruple my area. Okay. When the scale factor of the sides was 1/3, which was from which example? Oh yeah, the first example says scale factor 1/3. The area ended up being 1/9. An example that I did for you had a scale factor of 4/3, and then the area turned into 16/9. So let's summarize this pattern here. What is happening? If I go from 1 to 4, 1/3 to 1/9, 4/3 to 16/9, any number I have, whatever I do to the sides is going to do what to the area? It is going to, let's see, if 2 times 2, 1/3, 1/3 times 1/3, 4/3, 4/3 times 4/3. This is called r times r, which is called squaring it. Whatever you do to the sides, it's going to square it when it comes to the area. That makes sense, because if I measure sides in centimeters, I measure my area in centimeters squared. If I did my area in meters, my area is meters squared. R turns to r squared. Okay, are we all done? I think so. So you have homework, which is the rest. You have to read this graph on the grid. Where is the I? It is here. What is located in DH? What's this thing? Where part of BI is the chin? You're going to have to plot some points. You're going to have to do some new divided by old to get some scale factor stuff done. You should be using a calculator because it makes your life so much easier. Hopefully you're remembering things like radius and diameter, some geometry stuff. And the last one ended up on the next page, but the picture you need for number 5 is on the next page. Okay, do it to it.